Welcome to everybody. Probability and stochastic processes. In this class, we will see distribution and density functions. I am Dr. V. Ayambillai, Professor ECE GRIT, Hyderabad, India. First, let's see distribution function. The probability of random variable capital X being less than or equal to small x is called as cumulative distribution function of capital X. It is called as cumulative distribution function because the probability is distributed over the entire range, and as small x increases, the probability keeps accumulating or adding. We represent as follows. Capital X of small x is equal to P of capital X being less than or equal to small x. Fx of x may be called simply as distribution function. The following are the properties of distribution. 1. Fx of minus infinity is equal to 0. 2. Fx of infinity is equal to 1. 3. 0 less than or equal to Fx of x less than or equal to 1. 4. Fx of small x1 is less than Fx of small x2 if small x1 is less than small x2. 5. Probability of small x1 less than capital X less than or equal to small x2 is equal to Fx of x2 minus Fx of x1. 6. Fx of x plus is equal to Fx of x. Next, let's see density function. The probability for a unit range as the range becomes near to 0 is called probability density function. That is, the probability for a unit range of random variable as the range becomes near to 0 is called probability density function. That is, derivative of distribution function is called probability density function or just density function. The density function is notated as small f capital X of small x. Small f capital X of small x is equal to d fx of x divided by dx. That is, small f capital X of small x is equal to d capital F capital X of x divided by dx. Next, properties of a density function. 1. The density function is always non-negative. That is, Fx of x is always greater than or equal to 0 for all x. 2. Integral of minus infinity to infinity Fx of x dx is equal to 1. 3. Capital Fx of small x is equal to integral of minus infinity to infinity small f capital X of u du. That is, distribution function is the integration of density function. 4. Probability of small x1 less than capital X less than or equal to small x2 is equal to integral of x1 to x2 small f capital X of x dx. Next, let's see distribution and density functions for a discrete random variable. Fx of x. Fx of x, that is a distribution function can be written as sigma I is equal to 1 to capital N, P of capital X is equal to small xi into U of small x minus small xi, where U of x is a unit step function defined as 0, x less than 0, and 1, x greater than or equal to 0. Small f capital X of small x is equal to sigma I is equal to 1 to capital N, P of capital X is equal to small xi, delta of x minus xi, because delta of x is equal to du of x divided by dx. An example on distribution and density functions of discrete random variable. Let capital X have the discrete values in the set -1, minus 0.5, 0.7, 1.5, 3. The corresponding probabilities are assumed to be respectively 0.1, 0.2, 0.1, 0.4, 0.2. Draw a graph that relates distribution function to the distribution function to the random variable. This is an example for CDF of a discrete random variable. For less than -1 of the random variable, the probability is 0 for each value of less than -1. Hence, CDF for -1 is 0. That is, fx of -1 is 0. Fx of -1 is probability of capital X less than -1. At x is equal to -1, the probability is 0.1. Hence, capital Fx of x for x is equal to, that is small x is equal to -1, is probability of capital X less than -1 plus probability of capital X is equal to -1. That is equal to 0 plus 0.1 is equal to 0.1. Fx of x for x is equal to minus 0.5 is probability of capital X less than minus 0.5 plus probability of capital X is equal to minus 0.5 is equal to 0.1 plus 0.2 is equal to 0.3 and so on. For all values above capital X is equal to 3, Fx of for all values above small x is equal to 3, f capital X of small x is equal to f capital X of small x at x is equal to 3. The figure describes the distribution function of the random variable as the function of its values. We can see from the figure, for capital X less than -1, the distribution function is equal to 0. At x is equal to -1, there is a jump in the probability. So for x less than minus 0.5, the distribution function is the, the probability at x is equal to minus 1, and so on. This figure shows the density function of the given problem. The corresponding expression is small f capital X of small x is equal to sigma I is equal to 1 to capital N. Probability of capital X is equal to small xi into delta of x minus xi.